Hi there, it's Mr. Herman back with another video. This time we're going to be talking about the empirical rule. There is an empirical rule handout directly above this video on the website. You can use that to save you from having to copy all this down. Just print it out and then you can do the work right on this page just like I am. There are several parts to this problem. Let me read it out first. The following heights are a sample from a normally distributed group of 3.5-year-old unicorns. Using the empirical rule, find the percent of unicorns whose height falls between, this is an important part here, 14.5 inches and 40.6 inches. Those are, of course, all in inches. Round all figures to the nearest tenth after the calculations are made. That means, like, not in the middle of your standard deviation problem is what it's talking about. Just put it all in a calculator, get that amount, and then round it. So from here, we're going to take the amounts, and first we're going to calculate the standard deviation, because that's what you have to do. I know it doesn't say that here, but you'll learn that as we work on this, that to find these distances between here and to figure out the percent, you're going to have to use the empirical rule. And using the empirical rule, you need a standard deviation. So let's start with the standard deviation. That's going to be our first step. So we got x values and x squared. Let's just go ahead and list these out one at a time. I'll mark them off as I go so I don't miss one. You're going to want to then square each of these for this column. And remember, if I move too fast, you're welcome to stop this or pause this video to keep up. That's all of them. Okay, let's go ahead and square them now. After we do that, we're going to get the sums of these. Be very careful adding these. Always want to add them twice. And go ahead and add those up. Let's get a sum for this column here. This sum is 209. And the sum for this column is 5461. Okay, we can then put that into the standard deviation formula. So I'll put that right here. This is where you use that calculator with the second function and then the x squared button to get this prompt here, and then go ahead and put that extra parenthesis in there. Remember, we take the larger number first, subtract the smaller number, squared. I did notice on the quiz many of us forgot to square that number. It was the only real issue I saw with this besides putting it in the calculator incorrectly maybe. So let's make sure that that's squared. Then divide by the number of numbers there are, which looks like there are 9. Then divide by 8, which is 1 less than 9. And that formula, remember, will be on the test. It's also in your notes in your enrichment. You can use that all you need to. Not for the test and the enrichment, but of course you'll have it on the test. So put that in your calculator. Go ahead. I'm going to pause the video if you want and see if you get the right answer. That's actually giving me an approximate amount of rounded to 8.7. And that's actually in inches. It's the same unit as the other we're in. Alright, the next step we're going to need to do is find the mean. You have to find the mean because we're going to have to make one of these graphs like we did in class. And the mean goes in the middle. Excuse my curved graph, sorry, I'm not very good at making these. Should have a template to trace, it'd be a lot nicer. So the mean for this is taking 209 divided by the 9. So I'll take 209 divided by 9, 9 values in our list here, and we get a mean of approximately 23.2. Again, rounded to the nearest tenth, so it stays consistent for all the problems. So that mean goes in the middle. And then we have to add the standard deviation going to the right and going to the left. I always add it all 3 times. As you see me do in class, you don't just do it once or twice. Figure out all 3 of them. I'll drop it down to make it easier to see. Adding 8.7 to each of these, because we're adding 1 standard deviation above. This is 2 standard deviations. This is 3 standard deviations in the mean. So this is 31.9, 40.6, and then 49.3. We'll also subtract one standard deviation from each of these, coming down this way in the same way, taking 8.7 away again from 23.2 to give us 14.5, 5.8, and then we get negative 2.9, which doesn't really make sense because you can't really have a height that's negative, but it's okay. It doesn't make a difference for this problem. It'll work. All right, then after that, we're going to answer the question. So let's take a look at what's asking us. It's saying, using the empirical rule, find the percent of unicorns whose height falls between 14.5, so that's right here, I see that one right here, and 40.6. So I want to go ahead and shade that in so we can find out what that is. That's this part here. Since this graph is symmetrical, it makes more sense to kind of look at each part separately. So let's look at this part first. This part is in the center. Remember, we talked about how the empirical rule tells us that within one standard deviation of the mean, we have 68% of that data in the middle. And since it's 68% in the middle, this is symmetrical, this is half that. So that makes this part 34%, because it's half of the 68 from the middle. The other part is this part here. Let me use a pencil to shade that in. Up to 40.6 is this part over here. This part's a little more tricky because it's to the right more, so let's take this part. Consider again how this works. Within 2 standard deviations is 95% of the data. If I only want half that, I take 95% and I divide it by 2. Again, because it's symmetrical, that'll work. So take 95%, divide by 2, and use your calculator for that if you want. And you should get 47.5. So this part is 47.5%, the red. We want the total distance between the both, so we add them together. So add together 34 plus the 47.5%. That gives you your total answer of 81.5%. So 81.5% of the baby unicorns, actually they're not babies, are they? No, just unicorns. 81.5% of them fall between the range of 14.5 inches tall and 40.6 inches tall.